What is quicksort? Quicksort is a search algorithm that utilizes recursion. It is one of the more efficient search algorithms. Quicksort consists of 4 methods that I will be referring to as swap, partition, quicksort, and main. Quicksort needs all 4 of these to function. A swap helper method is required for the sorting algorithm. This is the same as the one taught in the array unit in class. It swaps 2 values in an array with each other. Quicksort can be divided into 4 steps. Step 1, the main method. First, the main method is run and quicksort is called and takes an array. Step 2, the quicksort method. The quicksort method checks the size of the array inputted. If the size is 1, it means the array is already sorted. If the size is greater than 1, it partitions the array, then quicksorts the subarrays. I'll now explain what partitioning does. Step 3, the partition method. The partition method's goal is to first split the array into 2 parts around a sorted pivot point, then returns the pivot point's index. How does it do this? It does this by first obtaining the pivot value. In this case, it will be the value at the end of the array. It then gets the partition index, which is always 1 less than the lowest index of the array. The partition index is where the array will be divided into 2. The partition method will then loop through all the values in the array and put values less than the pivot value behind the partition index and values greater than the pivot value in front of the partition index. It does this by testing if the value being checked is less than the pivot's value. If it is, it moves the partition index 1 to the right and swaps the value of the partition index with the value of the index being checked. It repeats this process until all values below the highest in the array, the pivot value, are sorted into groups that are greater than or less than the pivot's value. The pivot value is then placed at the partition index, which is between values that are less than the pivot value, which are on the left, and values that are greater than the pivot value, which are on the right. Now this is done by increasing the partition index to the right 1 place, then swapping the pivot value, which is at the end of the array, with the value at the partition index. The pivot value is now correctly sorted, and there are now subarrays with values that are greater than or less than the pivot. It returns the partition index, which is then used in the recurring quicksort methods. Step 4. Recurring quicksorts. Since the partition is now complete, quicksort then repeats steps 2 and 3 with the subarray with the values that are greater than the pivot value and the subarray with the values less than the pivot value. The process is continued until the subarray sizes are less than 2. The subarrays of 1 value have the values in the only possible and correctly sorted position. When the subarray's values are in the correct position, the array's values are also in the correct position. The process of quicksorting is now complete. Quicksort does not return a new array because it moves around the values in the initial array. The pros and cons of quicksort. The pros are that quicksort is more efficient than other sorting algorithms, which results in less memory being needed. It is fast, it is logically simple, and uses a divide and conquer strategy. There are methods to avoid the worst case, such as getting the median of the highest, lowest, and middle indices and using that as the pivot. It is better than other algorithms for large arrays. The cons are, it has unstable sorting, which can cause 2 indices with the same elements to swap order. The worst case scenario occurs when all the elements have the same value, the pivot is the rightmost element and the array is already sorted, the pivot is the leftmost element and the array is reversely sorted. The already sorted scenarios can be avoided by shuffling the elements and then sorting them. Quicksort is more difficult to implement versus other sorting algorithms. There are better sorting algorithms for smaller arrays.